You've been learning a lot about similar figures, and now we're going to learn another piece of information about similar figures, which is called scale factor. Sometimes we're given two shapes to look at, and we're asked to tell whether or not they're similar. And so here we have these two triangles, and it can be a little bit tricky to look at two shapes. They may look like similar shapes, but we want some way to test and prove that they're really similar figures, mathematically similar. So one way to test is to look at the corresponding sides of one figure, and they have to be multiplied by the same number to get the corresponding side lengths in the second figure. So for example, 4 times 10 would make 40. These are corresponding sides. 5 times 10 would make 50, and 6 times 10 would make 60. So I notice that I'm multiplying by that same number each time to get the other corresponding side. The other thing that has to be true is that corresponding angles are the same size. So again, I could compare these corresponding angles and make sure that they measure the same. So what we're focusing on today is this number piece, how we multiply by the same number, and that's called the scale factor. So the scale factor is the number that the side lengths of one figure can be multiplied by to give the corresponding lengths of the other figure. And what's important to know is that if the image is getting bigger, so if we're starting with our original and we're making it even larger, then the scale factor will be greater than 1. So think about how I could be doubling it, tripling it, quadrupling it. I could be multiplying it times 10, for example, right? The scale factor in that case is greater than 1. If the image is getting smaller, then the scale factor will be less than 1. So again, if I'm starting with an image and going to something that's a bit smaller, the number I'm multiplying by needs to be smaller than 1. So how do you find a scale factor? Well, you're going to start by looking at a pair of corresponding sides. So for example, here I have 2 and 6 as corresponding sides. And you're going to divide the side of the image by the side of the original. And think about how many times bigger or smaller the image is compared to the original. So let's do this as an example. So right now we're going to say the scale factor from the smaller rectangle to the larger rectangle is. So be careful, because this means that we're starting with the small and we're ending with the big. And so we're going from 2 to 6. And so we said earlier you can divide the side of the image by the side of the original. And so in this case, the image's side, right, this is the image, this is the new shape, is 6, and the original is 2. So 6 divided by 2 would give me 3. And sure enough, I can see here 2 times 3 makes 6. And so I'm going to just double check that down here as well to make sure I'm correct. And I see the sides are going from 3 to 9. So I'm going to think about how 3 times 3 is 9. And because they're similar figures, this works, right? They have the same scale factor to make both sets of corresponding sides. So I'm going to say that the scale factor from the smaller rectangle to the larger rectangle is 3. Therefore, the larger rectangle is 3 times bigger than the smaller rectangle. Now we're going to kind of practice going the other way. And so now you're going to think about going from the larger rectangle. So now the larger rectangle is the original to the smaller rectangle, which is going to become the image. So I have to think really carefully about what's happening here. Now my original is 6, and I'm going to 2. So if I take my image, just like I said up here, and I divide by my original, 6, right? So I have 2 as the image divided by 6, the original. I get 1/3 when I simplify it. So what that means is that 6 times 1/3 would give me 6 over 3 would give me 2. So before I had 2 times 3 makes 6, but if I'm going the other way, 6 times 1/3 would make 2. And so this scale factor is 1/3, and therefore that also means that the smaller rectangle is 1/3 of the size of the larger rectangle. So again, the big thing to think about here when you're finding the scale factor is this whole idea of the image divided by the original. So looking at two corresponding sides, take the new side and divide by the old side in the smaller shape or the original shape, and find how it changed, how many times bigger or smaller it became. So we have one more example to look at. Here it says that the triangles are similar. So that tells us there should be a scale factor between corresponding sides. So I'm going to look here from 12 to 6, and I want to think about what that scale factor is going to be. So from 12 times something to get 6. While we were talking about this a little bit earlier, you might be thinking about how it's 12 divided by 2. But 12 divided by 2 is the same thing as 12 times 1/2, because that makes 12 over 2, or 12 divided by 2, which would make 6. So this scale factor here is going to be 1/2. 12 times 1/2 makes 6. So again, I'm going to fill in the scale factor here. The smaller triangle is 1/2 of the size of the larger triangle. And now I'm going from the smaller triangle to the larger triangle. It's going the other direction. So from 6 to 12. That one's probably a little easier for you to see. That 6 times 2 would make 12. So my scale factor here is 2. The larger triangle is 2 times bigger than the, and you can fix this here, it should say smaller triangle. So now take a moment and think about, in your own words, what is a scale factor, and try to connect it to the idea also of corresponding sides.